Alright, so for today's lesson, we're going to be looking at lesson 4, dividing powers of 10. So we're going to be exploring patterns with exponents when we divide by powers of 10. So in past lessons, we've been multiplying. Here, let me erase that part. We've been multiplying stuff like this. That's equal to 10 to the 5th because we add the exponents. We've also done this yesterday. That's equal to 10 to the 6th because we multiply exponents. But then today, we're going to take a look and see what happens when we divide and see if we can formalize that into a equation. So, what is the value of the expression? What is this equal? Well, the numerator here, let's see, we have 5 copies of a 2, and then we have a 3 to the 4th and a 3 squared. Using this rule right here, we can add the exponents, so that's 3 to the 6th power. The bottom one, how many 2's? Well, we have 1 here. We have 5 there for a total of 6 2's. Oh wait, no, that's a mistake. I can't count. We have a total of 4 here and 1 here for a total of 5. Then we have a 3 to the 6th. If you think about it, we have 5 2's on the top, 5 2's on the bottom. So those are going to cancel. It's a big old 1. And similarly, 3 to the 6th over 3 to the 6th is the same thing as 1. So this is just 1 times 1, which is 1. Complete the table to explore patterns in the exponents when dividing powers of 10. So, if we look at this first expression here, 10 to the 4th divided by 10 squared, remember, this means division, okay? So this little symbol right here, that's division. 10 to the 4th is 10 times 10 times 10 times 10. 10 squared is 10 times 10. If you look at this, this cancels. This cancels. So you're left with 10 times 10, which is 1. Actually, let me turn off notifications. So we have 2 tenths, and that's just a 10 squared. Similarly, the second one, notice how we have 2 tenths in the bottom, so that's going to be divided by 10 squared. But how many tenths do you count in the top? 5 of them. 10 to the 5th. So you're left with 1 tenth, 2 tenths, 3 tenths, 10 to the 3rd. The expanded version, I'm going to go ahead and skip a step, but it's going to be 10 times 10 times 10 times 10 times 10 times 10, all divided by how many tens? 3 of them. So you could tell here, 3 of these will cancel, and you're left with 10 to the 3rd as well. Now this last one, let's be honest, are you really about to write 43 tens and 17 of them? No. Let's see if we can look at a pattern. In this first one up here, you had 4 tens on the top and 2 tens on the bottom, and you ended up canceling 2 of them. It almost makes me think of subtraction. 4 minus 2 is 2, and sure enough, that's what we get. In the second one here, we have 5 2's on the top, 5 tens on the top, 2 tens on the bottom, 5 minus 2 is 3, and sure enough, that's what we get. If we follow the pattern, 6 minus 3 is 3, and that's what we get. So the question we want to ask ourselves, what is 43 minus 17? I'm a math nerd. I can tell you that's equal to 26. Because 17 of those 10s will cancel. Bleh. So, we want to use the patterns you found in the table to rewrite 10 to the n over 10 to the m as an equivalent expression of the form 10 to the something. So, 10 to the n is equal to 10 times 10 times 10 How many times? N. 10 to the n is 10 times 10. How many times? M. And if you're dividing these, 10 to the n over 10 to the n, you end up subtracting the bottom number by the top number. And that is going to be the big takeaway for today, okay? You subtract the exponents when you divide. Let's take a look here. It is predicted that by 2050, there will be 10 to the 10 people living on Earth. At that time, it is predicted that there will be approximately 10 to the 12 trees. How many more trees will there be for each person? So, obviously 10 to the 12th is bigger. We want to know how many trees each person will have. Trees, people. Well, if we use this rule of subtracting exponents, 12 minus 10 is 2. So I know this is going to be equal to 10 squared trees per person. That's 100 trees. That's a lot of trees for a person. Are you ready for more? Heck yeah! So, this is tricky. We're gonna have, let's zoom in to make things easier. 10 times 10 times 10 times 10 over 10 times 10 times 10 times 10 times 10 times 10. How many will cancel? 4. Oof, we still got this one and this one. So it's gonna be 1 over 10 times 10, which is technically 1 over 10 squared. And that's also the same thing as 1 over 100, right? 10 times 10. 4.3. So far we have looked at powers of 10 with exponents greater than 0. That means positive, positivo. What would happen to our patterns if we included 0 as a possible exponent? Right? 10 to the 12 times 10 to the 0 with a power of 10 with a single exponent using the appropriate exponent rule. Explain or show your reasoning. Well, the exponent rule here is we're going to be adding since we're multiplying. So 10 to the 12 plus 0 is 10 to the 12. Which means 10 to the 12 is the same thing as 10 to the 12 times 10 to the 0. So what does this equal? What number could you multiply 10 to the 12th by to get the same answer? Oh, well, I know anything times 1 is equal to itself. Does this mean 10 to the 0 is equal to 1? I don't know! Write 10 to the 8th over 10 to the 0 with a single exponent of 10 using the appropriate exponent rule. Once again, that's going to be 10 to the 8 minus 0 because we subtract exponents, but 8 minus 0 is just 8. So this really makes me think 10 to the 0 is equal to 1. Why is Maestro boxing this? If we want the exponent rules we found to work even when the exponent is 0, then what does the value of 10 to the 0 have to be? How do I copy something? You know what, I'll just rewrite it. 10 to the 0 has to equal 1. Noah says if I try to write 10 to the Noah says if I try to write 10 to the 0 expanded, it should have 0 factors that are 10, so it must be equal to 0. Do you agree? Discuss with your partner. I kind of do agree with the homie. But He's forgetting. For example, 10 to the first is 1 times 10. 10 squared is 1 times 10 times 10. What's that, Durfee? So it makes perfect sense that 10 to the 0 would technically be 1 times something else, but that something else is non-existent. Oh my god, Illuminati confirmed. 10 to the 0 is equal to 1. 4.4, making millions. Write as many expressions as you can that have the same value as 10 to the 6th. Focus on using exponents, multiplication, and division. What patterns do you notice with the exponents? So first, let's look at multiplying, okay? Well, I know 10 to the 0 times 10 to the 6th is going to be equal to 10 to the 6th because we add the exponents. 10 to the 1 times 10 to the what? 5th equals 10 to the 6th. 10 squared times 10 to the 4th. 10 third times 10 to the 3rd, and so on. Once again, we can also do subtraction. 10 to the 6th minus 10 to the 0 is equal to 10 to the 6th. 10 to the 7th minus 10 to the 1st is equal to 10 to the 6th. 10 to the, 1,000 minus, why do I have to pick such a big number? 994, right? Because 1,000 minus 994 is equal to 10 to the 6th. So there's hella different ways. And then multiplying it, 10 to the 1st to the 6th, right? Because we multiply exponents here. 10 squared to the 3rd, right? Because 2 times 3 is 6. 10 to the 3rd squared. Last but not least, 10 to the 6th times 1. And if you really want to push yourselves, what does this have to be so that it's equal to 10 to the 6th? So in this case, this lesson, Jesus Christ, no Fortnite, not right now. For this lesson, really the idea here that is, if you take this exponent here, 9, and you take this exponent here, 3, and you subtract them, 9 minus 3 is equal to 6, and sure enough, that's what it's supposed to be, okay? So if you want to get a tattoo, maybe not this formula, but this can suffice. Oh yeah, and we forgot about this bad boy here. 10 to the 0 is equal to 1. I want you to get a chance to try the homework out. So try it out first, okay? And then come back to this video and see if you were right or wrong. Alright, well, what does 10 to the 0 equal? Whoa, nothing wrote. What? Oh, that makes sense. Ha! This equals uno, which is the same thing as the word une in French, which is the same thing as, how do you say one? Oh, one, which is this beautiful number. No, this is equal to 10 times 10 times 10 over 10 times 10 times 10. 10 over 10 is 1, 1, 1. 1 times 1 times 1 is 1. Ooh, 10 squared. Well, that's 10 times 10 plus, that's just 10, plus 1. 10 times 10 is 100 plus 10 plus 1, which is the magical number of 111. Why did I box this number, not the other ones? I don't know. The mysteries of the unknown. Write each expression as a single power of 10. Oh, this is hecka fun. Watch this. The top is multiplication because we're at, well, sorry. It's multiplication, so we add them. So that's going to be 3 plus 4 over 10 to the 5th That's 10 to the 7th over 10 to the 5th. Now this is division, so this means subtracting the exponents. And if you need a visual aid, it's going to be 10 times 10 times 10 times 10 times 10 times 10, 1, 2, 3, 4, 5, 6, 7, all over 10 times 10, blah, 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 blah. You get the picture. How many are going to cancel? 5 of them, right? So we're left with 10 squared. This next one is kind of tricky. And if you kind of forgotten, 10 to the 4th technically has a denominator of 1. So when you multiply exponents, when you multiply fractions, you can multiply across. 10 to the 4th times 10 to the 12th over 1 times 10 to the 7th. Up here, we're multiplying, so we're going to add the exponents. 4 plus 12 is 16 over 1 times anything is anything, so that's 10 to the 7th. And once again, since we're dividing, we subtract the exponents. 16 minus 7 is 9. Ooh, this one's really nice because you can do a lot of things here. I would recommend you figure out what the heck this is. 10 to the 5th over 10 to the 3rd is going to be 5 minus 3 is 2, so that's 10 squared, all raised to the 4th power. Now this is from yesterday's lesson. When you take a power to a power, you multiply the exponents. I think you're getting the hang of this. It's going to be 10 to the, we're going to take the, we're going to take the exponents. 4 plus 5 plus 6 all over 10 to the 3 plus 7. It's going to equal 10 to the 9 plus 6 is 15 over 10 to the 10. And what do we do when we're dividing? You guessed it, we subtract the exponents. So 15 minus 10 is 5. The next one is kind of fun. We're taking a power to a power, so we're going to multiply. So that's going to be 10 to the 10 over 10 to the 6th, which becomes 10 to the 4th, because we're subtracting the exponents. You see? It's not that much, right? Right? Number 3. The sun is roughly 10 squared times as wide as the earth. And to put things into perspective, here's the sun. Here's earth. This is 10 squared times as big. The star, kilowatt Sagittari, is roughly 10 to the 5th times as wide as the earth. Okay, so we have another star, and that's 10 to the 5th. About how many times as wide as the sun as Sagittarius? So, here's how big this big star is. Here's the sun. So how many times bigger is one compared to the other? Well, we would do 10 to the 5th divided by 10 squared. Since we're dividing, we're going to subtract the exponents, and that's 10 to the 3rd times as big. It's pretty big. Banana costs $150 per pound. I'm just going to box that in. And guavas, what are guavas? Oh, guayabas are $3 a pound. Kieran spends $12 on fruit for a breakfast his family is hosting. Let B be the number of pounds of bananas Kieran buys and G be the number of pounds of guavas he buys. Write an expression relating the two variables. Oh, this is awesome. Write an equation. Okay, so we know B represents number of bananas. More specific. Wait, I have an eraser. More specifically, number of pounds of bananas. bananas. Thank you, Gwen Stefani. Number of pounds of bananas. And then we have G represents the number of pounds of guayabas. Since each pound of banana is $1.50, we can write 150B. This is the total cost for bananas, plus 3G. This is the total cost for guavas, and that's equal to how much money did homie spend, or homegirl? $12. It's a lot of fruit. Rearrange the equation so B is the independent variable. This means we want not B to be solved for. So we're going to want this in G equals ... Sorry, I should have written that over here. We want G equals. So if our equation is 1.50B plus 3G equals 12, we want to solve for G. That's pretty easy. Psych! We subtract 1B from both sides. Right, here's a little equal sign. That's a 0, so we have 3G is equal to, we can't combine these since they're different. And then the opposite of multiplying by 3 is dividing by 3. So G is equal to negative 150B over 3, which you can use on your calculators, negative 50B plus 4. Yes, Derpy, yes. That's negative 50B plus 4. They wanted to do the same thing, but now solving for B, right? Because G is the independent variable, so they want the equation in B equals. We're going to do that right here. 1.50B plus 3G is equal to 12. We want to solve for B. So we're going to subtract 3G from both sides. Hey, nobody has 3G internet no more. 150B is equal to negative 3G plus 12. And we're going to divide both sides by 150. So B is equal to negative 2G plus, quick maths, 9. Yes, therapy. So the equation is going to be B equals negative 2G plus 9. I know it seems like a lot of work, but a lot of this is actually review, okay? So if this sounds new to you, it's okay. It's been a rough week, and it's only Monday. Last one. Lynn's mom bikes at a constant speed of 12 miles per hour. Lynn walks at a constant speed of 1/3 of her speed. Her mom bikes. Sketch a graph of both of these relationships. So we know Lynn's bike can travel at 12 miles per hour, okay? Which means in 1 hour, how many miles can she travel? 12 miles. 1 hour equals 12 miles. But notice how we don't have 12 miles here. So let's do 0.5 of an hour. How many miles is that if it's half an hour? 6 miles. Derby, don't bark. You barked in my ear, bro. Bro. Derby. I'm trying to record a video here, okay? Derby, you ain't finna get cheese. Derby, it's okay. All right. So, zero point 0.5 hours means 6 miles. So here's 0.5 of an hour right there. And then if you have a ruler, you can make this look really nice. Okay? Now, Lynn walks 1/3 of her mom's speed. So if her speed is 12 mph, miles per hour, and it's 1/3, what is 1/3 of 12? Yes. How much is it, Derpy? Yes, I agree with you. It is 4 miles per hour. If you don't know why, 12 over 3 is 4. That's why. So in 1 hour, we can actually do this one. Land bikes 4 miles per hour. And that's it. Thank you all so much for being here. Please wash your hands, drink water, and according to the CDC, don't go anywhere.